Both of these compressors have current relays, but one of them has a current relay that attaches to the actual compressor terminals, and the other one has a current relay that is located in a separate electrical compartment and wired then to the compressor terminals. They both function the same, so using an ohm meter to test them changes a little bit because of the way they wire physically up to the compressor terminals. This current relay is the type that pushes onto the compressor terminals. So this would be the run terminal, and this is where it would push on to the start terminal. One of the power leads would connect up to this terminal right here, and then that power goes through the coil, out of the coil, and this is an electrical connection inside there that goes to the run terminal. At the same time, one of the power leads can go through the start capacitor, if you have a start capacitor, and then to this terminal here. This is one side of the electrical contacts, and then when the contacts close, then it energizes through the contacts to this terminal to energize the start windings. Notice there is no common terminal. That comes through the overload. So the overload this particular overload has a push connection for the common terminal. Here's another style of overload, and that would have a wire coming into it for the common of the compressor, and then a lead coming out of the overload to the actual electrical terminal on the compressor. So testing this type of relay right here. If we want to check the coil, we would put one lead here and one lead on this terminal, and that should be a very low resistance coil, and that's what we're getting on the meter, is a real low resistance. If we want to check the contacts, we would put one lead where it connects to the start windings. I'll hook up an alligator clip so I can work hands-free on this other terminal. The actual contacts between these two right here. So with the relay in the normal position like it would be on the compressor, there is no continuity, and there shouldn't be because contacts on a current relay are normally open. We can check these though by turning the relay upside down because they are gravity contacts. And sure enough, when we turn it upside down, we get continuity. So that's testing that current relay. That's the type that pushes onto the terminals of the compressor. If you've got the type that mounts separately from the compressor terminals, like this one right here, the contacts are in the bottom of the relay. So when there's high inrush current, this is pulling those contacts closed, normally open contacts. We're showing no continuity right now, OL, over the limit, so no continuity. And again, if we turn that upside down, we get continuity. So those contacts are working correctly. This one here, if we wanted to check the coil, you can actually see where the coil connections are. So we can put a lead here, and here visually we can see where the coil is. And right now that's showing showing 0 ohms. I'm sure there's some ohms there. It's not an open, so it's just showing extremely low ohms. perhaps at least 1 ohms we should have there. That coil is probably just fine. Not sure why it's showing just 0 ohms. So on this particular one, this lead here would go to the run winding. So power would come into here, go through the coil, come out of the coil, go to the run winding, and then we would also come from here to, if we have a start capacitor, come through a start capacitor to this side of the contacts. When there's high inrush current, it would close these contacts. Then that start capacitor would feed through the contacts to the start winding. And this terminal here then would be wired up to this terminal of the overload, out of the overload to the common of the compressor.